Hello. In this video, I'm going to be explaining problem 2 from the 2012 F equals MA contest. In this problem, we have a pretty classic projectile motion problem. So we have a cannonball launched with initial velocity v0 over a horizontal surface, and we're asked what is the minimum angle theta min such that the maximum height h that it reaches on its trajectory is larger than the horizontal distance r that it covers. So this is the horizontal distance r, and this is the height h, and we're asked for theta min such that h is greater than r. So what we will want to do naturally is compute h, compute r. Both of these are relatively simple projectile motion problems, and then find the angle at which these two are equal. And for larger angles, h will be greater than r, and for smaller angles, h will be less than r. So we can do this in general. Let's say we have an angle theta, initial velocity v naught. We have some trajectory like this. Now, we know that the projectile motion can be split into v0 in the x direction. So let me define my axes. This is horizontal is x, vertical is y, v0x, which is v naught cosine theta. And we have a vertical velocity initially, which is v0y, is v0 sine theta. Now, we know that there at any point, let's say this is our cannonball, there will be a force mg, and really the acceleration will be downward by the quantity g. And so what we can do is we can fairly easily solve for v0x and v0y as a function of time, or v sub x and v sub y, excuse me. So v sub x will always be v0x, which is v naught cosine theta, because there's no force in the x direction, while vy will be v naught y minus gt. And so that'll be v naught sine theta minus gt. Now, we can ask what time t will this be such when the cannonball reaches its maximum height? Well, all we need to do is set v sub y equal to 0, and that will quickly tell us that capital T is equal to v naught sine theta over g. Now, the total time of flight, this path, one can fairly easily see that it's symmetric, and so this will just be equal to 2t. Another way to see this is that by the kinematics equation that the total displacement will be equal to the initial velocity plus the final velocity over 2 times the time. Since this projectile reaches the same y level that it started with, namely the ground, for this to be 0, the final velocity would actually have to be negative of the initial velocity in the y direction. This is all in the y direction. And that means that the time would just have to be twice as much the time to reach 0 velocity, since the acceleration is constant. This is one of the big 5 kinematics equations, or equations of constant acceleration kinematics, that you should commit to heart. So with that being said, we can now compute the distance h. So the height h will be 1/2 times the acceleration in the y direction g times t squared, and that will be 1/2 times g times v naught squared sine squared theta over g squared, and so we get h equals v naught squared sine squared theta over 2g. Now, let me go to a new page. Now we know that the range will just be the velocity in the x direction, which is v naught cosine theta, times 2t, because 2t is the total time of flight. So it will be v naught cosine theta times 2 v naught sine theta over g. And that equals 2 v naught squared sine theta cosine theta over g. We could re-express this as v naught squared sine of 2 theta over g. And this is helpful in some scenarios. For example, one can now obviously see that the range is maximized when theta is 45 degrees, and that is useful for other problems. But in this case, we're not going to do that. We're going to leave it in this form, because that will let us easily tell when h is equal to r, because we'll get lots of cancellation. So to check when h is equal to r, we will have v naught squared sine squared theta over 2g equals 2v naught squared sine theta cosine theta over g. G is in the denominator in both cases. That cancels. 1 power of sine theta will cancel. V naught squared will cancel. And so what we end up getting is that sine theta over 2 is equal to 2 cosine theta, or in other words, tangent of theta equals 4. So or theta equals arctangent of 4. Now, 4 is not the tangent of any common angle. So at this point, you would just have to go to your calculator or some other, or maybe if you're blessed with amazing computational powers, you could figure this out. But the best thing to do at this point would just be to go to your calculator. I actually don't know what this angle is exactly, so I'm just going to go ahead and find it right now. And what we get is that this is about 75.96 degrees. Now, we go back to our problem, and we indeed see 75.96 degrees is right around 76 degrees, and so this right here is our answer. All right, so that's all there is to this problem, and I hope that was helpful. Thank you for watching.